So today we're going to change our topic and we are going to go back into Earth and space. So our learning intention for today is to understand why there are seasons, why there are phases of the moon, and why we have eclipses. How do they happen? Now, if we were doing this in school, we'd be doing it a lot differently than we are now, but we'll do our best. Okay, so this is our learning intention. So the first thing I'm going to do for you is play a little video clip, and I would like you to please to look at how the Earth moves around the sun, how the moon moves around the Earth, and probably the easiest part to look at when you're looking at the Earth is look at the position of Africa in the Earth and see, does it change as it rotates. So we have the Earth on the right hand side, and I'll leave this play until the Earth gets to the left hand side of the moon, and I want you to look at the position of South Africa or Africa and see how that changes, because we're going to need that in a little bit later. Alrighty, I'm going to stop that there and I'm going to go back to here. So we now have to draw a model of the sun, earth and the moon. So and how they relate to each other. So we will draw our sun as a big yellow ball in the middle of our page. We will draw the earth as a sphere, and I'm going to mark an X where Ireland is, and the earth orbits the sun as that movie clips showed us. So I'm hoping when you were looking at it you noticed that South Africa, because it's really big, changed its position depending on if the earth is on the right side of the sun or the left side as we're looking at it. We then have our moon, and as our earth is going around the sun, the moon goes around the earth. And obviously one whole revolution of the earth around the sun is 1 year. So we're calling this an orbit, and we're calling one whole revolution of the earth around the sun well, that is equal to 1 year. And we have one revolution of the moon around the earth. That is 28 days. So not quite, well, it's the month of February. So they are our pathways and our orbits, and we're going to now come and have a look at how the position of the earth is, or how Ireland, the position of Ireland will change as the earth rotates around the sun. So pause this if you need to, otherwise we are going back to here. So we've done our model. You can take the time now. You need to write this out for yourself, and you need to fill in the blanks, and one blank will be used one time. So pause and put them in, and this is going to be our explanation for day and night. Now, we're going to another movie clip is going to explain to us why we have seasons.
Ah, the seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth, and there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're on the part of the Earth that's toward the sun, it's daytime. And when you're on the part of the Earth that's away from the sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia.
Hey, Bill, your shoe's untied.
Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons.
Alrighty, so we're now going to have a look at that. So winter in Ireland. Why is it winter in Ireland? Why is it summer in Australia and New Zealand? It's because the tilt of the Earth's axis makes the northern hemisphere further from the sun, and now we're in winter. So if we were drawing our diagram like this, we would put our sun over here. We would draw our perfect circle, like so. And if you want to put Ireland up here, we're here. But this is the important part, the fact that this is the line on which our Earth spins. So if you actually have a globe at home, you will see that it is at this angle. We're not interested in the angle, but just to the fact that we have a rotation axis. We can put in our Arctic circle, we can put in our equator, and we can put in the Antarctic circle, and we can put the X, that would be us. So our tilt is further away. So we're tilted away from the sun. Okay, if you want to put in our arrows for our sunlight, you can. So if you notice then down at the bottom, this part is now closer to the sun down here. So these guys have summer. So similarly, when it's now summer in Ireland, the tilt of the Earth's axis makes the northern hemisphere closer to the sun, and now we have summer. We're also in a different position. The sun is now on a different size because of the orbit that we've taken. So this is our sun, this is our Earth. We still have our Arctic circle. We are going to put now Ireland, X marks the spot, probably just about over a little bit, but we'll mark it in. We have our equator, and we have our Arctic circle, and we are now the thing that is tilted closer to the sun. So therefore it is going to be warmer for us, whereas down here they are now the tilt that's further away, and that's why it's winter in the southern hemisphere. So pause this if you need to, and draw your diagram and write your blurb. Now we have to talk about the lunar phases, and the lunar phases are just a posh way of saying the phases of the moon. So the lunar landing is the moon landing. So lunar is what they use to refer to the moon. And again, we have another video, and we would have done this again differently in school, but we will put this on for you now.
To the sky on a clear night, most likely you will notice the moon. You will also notice that it doesn't look the same every night. Welcome to Moomoo Math and Science and the phases of the moon. The moon revolves around the Earth roughly every 27 days. As it revolves around the Earth, it goes through phases. Here's what these phases look like. But why does this happen? The sun, Earth, and moon, along with their movements, causes the phases of the moon. The Earth revolves around the sun, and the moon revolves around the Earth. Let's take a look at this. The moon cycle, or lunar cycle, begins at new moon. Here's the alignment of new moon. And here's what new moon looks like from Earth. And yes, it is very dark. The moon travels roughly 13 degrees in 24 hours. So after roughly 3.5 days, the moon has moved 45 degrees and is at waxing crescent. Here's the alignment. Waxing means that the sunlight is getting larger, and crescent is the shape. And here's what it looks like. In 7 days, the moon has now traveled 90 degrees and is at first quarter. Here's the alignment. Remember, the sunlight is always on the right in first quarter. I remember to be first, you must be right, and the light is on the right. Also, the shadow moves from right to left. In an additional 3.5 days, it has now traveled 135 degrees and is at waxing gibbous. Check out this alignment. Gibbous is the shape, and remember, waxing means the light portion is growing. After 14 days since new moon, the moon has now traveled 180 degrees and is at full moon. Here's the alignment, and here's what a full moon looks like. After another 3.5 days, the moon is now at waning gibbous. Here's the alignment. Waning means the light is getting smaller. And here's what it looks like from Earth. Again, remember, the shadow moves from right to left. After 21 days, the moon has now traveled 270 degrees and is at last quarter. Here's the alignment. The light is now on the left. And I remember, if you got last, you got left behind. After roughly 24 days, the moon is now at waning crescent. Remember, waning means the light is getting smaller. And the sun, earth, and moon alignment looks like this. And finally, after roughly 27 days, the moon is now back at new moon, and the lunar cycle will start over again. If you'd like to know more about the phases of the moon,
alrighty, so we now have to draw the phases of the moon. And I'll put a proper picture of this up as well in the video, but we are going to leave our sun over here. Obviously the sun is going to be ginormous. I'm going to make the moon is going to be in white. You also have black pencil or pencil that you can use, and we are going to put our earth here in blue. So here in this position, this is what is called new moon. And when we see it, it's essentially dark. You can kind of get the outline of the moon, but it's not really there. We are going to go all the way to the other side. So when we see completely bright colored in moon, that is our full moon. So this is a full moon. We have down here, we are going to put what is called first quarter. And when we're on first quarter, we see half of the moon. So we're always seeing the moon from the right. Now the quarter is really coming from the number of days. So this is first quarter. And over here we are going to put last quarter. So when you're on last quarter, the sun is now going to be on the left. So we have 4 more phases that we have to put in. So we are going to put a phase in here. So the outline, while the outline is white, technically it should be black, but I don't have black for this. So at this little section, we now have just a sliver of moon that we can see, a little crescent. and it is called a waxing crescent. So waxing just means the light is getting bigger. So here at the new moon there was no light, but now we have a waxing crescent. And when the moon is about 3/4 of the way to half moon, we have what is called a waxing gibbous moon. So again, waxing just means the light is getting bigger and we can pretty much see most of the moon. So gibbous is the word they use to describe that. So just get this colored in for you. So we're not quite full, but we're getting there. So then after full moon, we now are on the waning side of things. And again, waning means the light is getting smaller. So now we will have a dark crescent on that side. And we're now losing light from the right hand side. Whereas earlier the light was starting to appear from the right hand side. So this now is a waning gibbous moon. And the last section that we will have will be a waning crescent. So when we're at the waning crescent, we now have this sliver over here. Now I'm not 100% sure how the SEC will ask you this, so you just have to, I suppose, learn it in your head. And our moon is moving in, this is our orbit.